Hello students, very good afternoon to you. Now I'm going, before I start with this with linear concurrence, means unit 2 of elementary number theory, there are some basic definitions that I need to explain to you which are in unit 1. So there are definition of divisibility and its basic properties, and next is definition on concurrence. So here let us just recall here what is the set of integers. Set of integers is the collection of all points of the form 0, plus or minus 1, plus or minus 2, and so on. Now next come the definition. We have, you consider two integers a and m belong to set with m different from 0. M different from 0, it means that it can be plus or minus positive or negative integers. Then we say that m divides a if there exists an integer k belong to set such that a can be expressed as m into k and is denoted by m. If a is equal to mk, then we write m divides a. So here, for example, you take a here is equal to 6, m is equal to 3. Then by according to definition of the above definition of divisibility, means that for a equal to 6, when you divide it by m, that is 3, there exists a positive integer 2 here, such that is k here is equal to 2, such that 6 can be expressed as 3 into 2. So we say that if 3 divides m, this implies that 3 divides 6. So in general, if a divides m divides a, it means that m divides a, then a is divisible by m, or we can say that m is a factor of a, or m is a multiple of a. So I hope it is clear to you what is meant by divisibility. For any m belong to set with m different from 0, if there exists and we say that m divides a, or if there exists a positive integer k such that a can be expressed as m into k, then we call m divides a, or a is divisible by m. As you can see in the above example, a is equal to 6, m is equal to 3. 3 always divides 6. Why? Because there exists an integer k is equal to 2, such that 6 can be expressed as 3 into 2. And these are some of the basic properties of divisibility. First basic properties is that for any a belong to set a different from 0, a always divide itself. Why? Because you can always express a as 1 into a, that is, there exists an integer 1 belong to set such that a can be expressed as 1 into a. So this shows that a always divide a. Second property is that if a divides b and b divides c, then what we have to show is that a divides c. How we prove it? A divides b, by definition of divisibility, m divides a, it means that a can be expressed as m into k. Now if a divides b, it means that there exists an integer k1 belong to set, belong to set such that this b can be expressed as a multiple of a, that is a into k1. Similarly, b divides c, it implies that there exists an integer k2 belong to set such that this c can be expressed as b into k2. Name it as equation 2 and this one as equation 1. Now from 1 and 2 we have, combining or using 1 and 2, we have c is equal to bk2. Now what is b from equation 1? It is equal to a into k1. So replace b here by a into k1. Now what are k1 and k2? K1 and k2, they are integers. So the product of two integers is again an integer. So I'll write this product as small k, where k here is k1 into k2 belong to set. So this implies that c is equal to a into k. Or we can say that c is a multiple of a, which implies that a divide c according to the definition of divisibility. Now third properties is, or basic properties is, that if a divides b and a divides c, then a must divide bx plus cy for any xy belong to z. Now what is the proof for this? A divides b, again using definition of divisibility, implies that there exists k1 in z such that b can be expressed as a into k1. Next, a divides c implies that there exists k2 belong to z such that c can be written as a into k2. Now bx plus cy, you consider this. Okay, you multiply this this equation by x and this equation by y. So bx will give you ak1x and cy will give you multiply this by y, you will get cy is equal to ak2y. So at bx plus cy, what we have here is ak1x plus ak2y. Now as you can see here, a is common. So take a common, write the term, this uncommon term inside the bracket. So we have a into a k1x plus k2y. Now what are these integers? k1, x, k2y, they are all integers. k1 into x will be an integer, k2y also will be an integer. The sum of two integers is again an integer. So this shows that bx plus cy is a multiple of a. So if it is a multiple of a, it means that a divides bx plus ay. I hope it is clear to you. Number 4 is that if a divides b, it implies that the number 4 follows from the above property 3, that is basic property 3. If a divides b, implies that a divides bx. Why? Because as you can see here, a divides b, it implies that b can be expressed as a into k1 for some k1 belong to z. Now multiply this by x implies that bx is equal to a k1x, where for some integer x belong to z. So as you can see here, k1 into x again will be an integer. So therefore this implies that bx is a multiple of a. So this implies that a divides bx. Now the proof of this one, if a divides b, implies that a divides b to the power k, where k belong to c plus, here it is a positive integer, this k, because it is a power here. So what we have is, you just replace this x. The proof of this, you just replace, put x is equal to b to the power k minus 1. Okay, b to the power k minus 1. Yeah, in this relation, a divides bx in 1. So this implies that a divides b into b to the power k minus 1. But b to the power k, by law of indices, this will be equal to b to the power k. So this implies that a divides b. So I hope it is clear to you this definition of divisibility and some of its basic properties needed for unit 2. Okay, it will be, I think, the teacher who is supposed to take this unit again will discuss all those basic properties in detail. So for me, for the time being, I'm just explaining some of those important basic properties on divisibility. So let me okay, for example, if I take a here is equal to 7 and m here is equal to 3. Is a divisible by m? No. Why? Because a here, 7, can you express, if you divide it by 7, so 7 if you divide it by 3, so 3 into 2 is 6, so the remainder will give you 1. So if I divide here, so this 7 can be expressed by 3 into 2 plus 1. So in this case, if the remainder is not equal to 0, so this implies that m does not divide, and this implies that m does not divide a, that is 3 does not divide 7. And if I take another example, say a is equal to 12 and m here is equal to 4. Does 4 divide 12? Yes. Why? Because this 12 can be expressed as 4 into 3. That is, there exists and some integer k equal to 3, such that 12 can be expressed as a multiple of 4, that is 4 into 3. So this implies that 4 divides 12.